Hello. Today we'll be looking at the 2013 Middle School Math Olympiad questions. So let's get started. The hexagon shown has the line of symmetry BE. The measure of angle FAB is 150 degrees. The measure of angle ABC is 114 degrees. And the measure of angle DEF is 100 degrees. What is the measure of angle CDE? Now before we jump into this question, it's important to understand what the line of symmetry is. The line of symmetry is an imaginary line that divides an object in two equal parts by a mirror image reflection. Let's look at an example. For instance, this pair of glasses. If we unfold these glasses, we can see that the line of symmetry would be cutting these glasses in half, as the left side of these glasses could be mirror image and reflected on the right side. Furthermore, the line of symmetry also has some properties. For instance, the stem of the glasses on the left side would have the same length as the stem of the glasses on the right side. Aside from everyday objects, we can also look to geometry to see the properties of the line of symmetry. For instance, this triangle. We can see that the line of symmetry would directly bisect this triangle in half. We can also see through the properties that the line of symmetry has that the left side of the triangle could be reflected on the right side. This would allow for the measurements of the line segments as well as the angles to also be the same. For example, the length of this segment would be the same as on this side. The base of this triangle would have the same length as the base of this triangle. And finally, the measurement of this angle would be the same as the measurement of this angle. Now that we've seen the properties of the line of symmetry and we know what the line of symmetry is, let's go back to the original question. Through this question, we can see that the line of symmetry would be at BE. We can also see that the line of symmetry directly cuts the hexagon in half by creating two quadrilaterals or irregular trapezoids. These trapezoids would also share the same measurement. For instance, segment FE has the same length as segment DE. Segment AF has the same length as segment CD. And finally, segment BA has the same length as segment BC. Aside from the similar lengths, they would also share the same angle measures. For instance, angle F has the same measurement as angle D. Angle A also has the same measurement as angle C. Now that we've seen the properties of the line segment, let's go back and reread the question. The measure of angle FAB is 150 degrees. Here we have FAB, which is 150 degrees. The measure of angle ABC is 114 degrees. And finally, the measure of angle DEF is 100 degrees. Now that we've looked at the angle measures that are given by the question, let's look back to our properties. Through our properties, we can see that the measure of angle A is equal to the measure of angle C. Therefore, As angle A is 150 degrees, angle C would also be 150 degrees. Now, looking back to the question, we can see that it is asking for the measure of angle CDE. As the measure of this angle is unknown, and it is what the question is asking for, we must assume it through a variable. In this case, let's assume the measure of angle CDE as x degrees. Now, to find the measure of CDE, let's start by setting up an equation. As we know the measurement of angle C, angle D, we now need to find the measurements of angle DEB as well as EBC. We can use this angle measurement to create an equation that is equal to the sum of the interior angles of this quadrilateral, which we'll get to. So first, let's start with finding the measurement of angle DEB. As we know, the measurement of angle E is 100 degrees, and that the line of symmetry bisects this angle directly in half. We know that the measurement of angle DEB can be found by dividing 100 by 2 to get 50 degrees. Similarly, we can find the measurement of angle EBC by dividing 114 by 2 to get 57 degrees. Now that we know all the interior angles, 50 degrees, 57 degrees, 150 degrees, and x degrees, let's set up an equation. But first, we need to find the sum of the interior angles of this quadrilateral. For this step, we can use an equation. This is a formula for the sum of the interior angles, which is equal to 180 times n minus 2. In this case, n is equal to the number of sides of the shape. As this is a quadrilateral, it has 4 sides. Therefore, we can use the equation and do 180 times 4 minus 2, which can be simplified to 180 times 2, which is equal to 360 degrees. Now that we know the sum of the interior angles, as well as all the interior angles of this quadrilateral, let's set up the equation. $50 degrees plus 57 degrees plus 150 degrees plus x degrees is equal to 360 degrees, or the sum of the interior angles. We can simplify this equation down to get the value of x, which is equal to 103 degrees. As the question is asking for the measure of angle CDE, which we assume to be x, we know that the measure of angle CDE is 103 degrees.